Okay, guys, I'm gonna share my screen in a moment. And we'll give it another 30 seconds and then we'll get going because I've got quite a lot to get through, a lot of value to share with you as well. And there'll be time at the end for questions. Okay, so let's get into it, and people can come and go as they please as we get going. So thanks so much for joining wherever you are in the world. I appreciate you taking an hour, 1 hour out of your day to go through this. Hopefully you'll get a lot from the session. I've run it quite a few times now, and the feedback's always quite positive. So I'm going to go through a bit of background about myself and about the Master in Snowflake program. And then we're going to have about 25 minutes, 30 minutes in terms of a high level training session with regard to the Snowflake architecture, which I think you'll find pretty interesting and quite valuable, especially if you're new to Snowflake as well. So let's get straight into it. So a lot of the members come to me on my program because they're stuck working with legacy technology. And I really hope that your office doesn't look much like this or your day job, because many people are stuck working with on-premise legacy technologies such as Teradata, Oracle, etc. And their organizations have failed to invest in technology and also failed to invest in their employees in terms of keeping them up to date with the latest skills. And it's not much fun at all. And I help my members become a real expert in data analytics in the cloud. And so you could really be as cool as this guy too. And it's really those people that can demonstrate real world experience and the know-how to really get business value out of cloud-based technologies. They're the ones that work on the most exciting projects. They get highest remuneration and they get the best, most exciting jobs. And so this is the type of people that I help. I help them going from being stuck, working with all that legacy technology, doing all those laborious tasks to kind of really supercharge their career and work in the cloud. So settle in and stick around if you're a data analyst or data engineer, or a data architect wanting to break into design and implementing the latest cloud-based data platforms. I'm looking for people as part of this program, as part of this session, who want to work smarter and really kind of use their existing experience working with commercial databases. It's not unusual for me to have members on the program who've got 10 to 15 years of experience and expertise, and they want to take all of that kind of investment that they've put into their own careers and themselves and work out how best to translate that into cloud-based technologies. And often those people haven't got time to spend unnecessarily, so they don't want to go off and try this course over here, try this course, which may or may not necessarily get them the right results. These people are looking for a real kind of proven roadmap to get to becoming an expert in Snowflake, in cloud-based technologies in the shortest amount of time. And as I mentioned, a lot of my members already have a background in databases and they want to take their knowledge to the next level. These people are also looking to immediately enhance and future-proof their career opportunities. So a lot of the members that join my program have recognized that they're stuck in a dead-end career and they need to do something about it and need to do something quite quickly. And once they finish the program or complete the, a number of modules of the program, which we'll get into shortly, they're able to confidently walk into any job interview really and explain how to use Snowflake in the real world to address common kind of challenges. So I'm assuming you're not these people because you've made the time out of your day, out of your evenings to be here, which is really great, and I really appreciate it. But some people come to me and they just kind of want information, but they don't take any action, or they just want to learn, one of the many programming languages out there, Udemy or Code Academy, something like that's the place for you. What I'm offering is real kind of transformation from a career perspective. Also, if you're not serious about growing as a person and improving your career prospects, this probably isn't the place for you, as is being in an average job with an average salary. So I'm going to give you as much value as I can. I'm going to give you a bit of background about myself and about the program before diving into the training session. I'm going to go through as much as I can there. Stay to the end, though. I'll leave at least 5 minutes for Q&A, where you can ask me anything about the program or Snowflake or anything else that's on your mind as well. So before we get into that, let's go through some of my background and kind of what brings me here today. So I started my career working in data analytics way back in 2001, which seems like a very long time ago now. And when I got into IT, I quickly realized that I really wanted to be the best at what I did and become my own boss and help as many kind of clients as I could. So I started my own kind of data analytics consultancy when I was 24, and kind of I had a real thirst for knowledge and a thirst for learning, and I kind of went through all the certifications of everything at that time. And I was able to kind of work quite flexibly and never needed to look for any work or any job. I was quite fortunate in that regard, where I was able to kind of build relationships and work with people and really add value to those clients. But even then, I was soon to be stuck working with legacy technology. Cloud computing started to take off somewhere around sort of 2016, 2015. And I really needed to find a way to break into that. And I felt I was at risk of being left behind. And I was looking over my shoulder, looking at some of my colleagues who were working with much more exciting, newer technologies. And some of this might resonate with yourself, that it was just very confusing where to start. Lots of new terminology out there, a lot of new technologies which seem to have overlapping capabilities as well, made it really difficult to know where to kind of pin your hopes and what to focus your attention on. So in 2017, I was lucky enough to be introduced to Snowflake, and it was really like a breath of fresh air from the world I came from before. A lot of the administrational tasks you often associate with those on-premise legacy systems simply just aren't required anymore. But it was still really hard for me to get hold of good, real-world content that I could apply today or read today and apply tomorrow. And that, even though we're talking 5-6 years ago, this really is still the case for me in regards to Snowflake at the moment. There's a lot of documentation on the Snowflake website. However, it's very theoretical and it doesn't get into really tangible kind of outcomes. So it was really quite time consuming and painstaking work to kind of research and test. Does this kind of feature work well if I package it up in this way, and kind of what doesn't? And Snowflake has new features, and that requires a different way of thinking. And often what I see with my clients is they'll move from Oracle on-premise or Teradata on-premise, for example, go to Snowflake in the cloud. They'll lift and shift all of their data, but also they'll lift and shift all of their existing legacy processes into the cloud. And in doing so, they'll not realize a lot of the value that Snowflake can offer as well. So it really does require a different way of thinking and a shift in mindset to really get the maximum value from a cloud-based Snowflake implementation. Now, fast forward to today, in numerous implementations of Snowflake later, I've found what works and what doesn't. For time-consuming work, through the trial and error. And in short, I had a recipe or a set of recipes that worked. And I decided to start a YouTube channel to start sharing some of my knowledge with the community, so you guys out there as well. And mid last year, I was approached by Apress to write a book around Snowflake because they recognized the value that those formulas and recipes could also bring to others. So I kind of packaged them up as part of that, part of writing that book, and was able to kind of share that more widely so people could avoid the same pitfalls. So it took me from where, I started with no cloud experience, and this might be one of you guys on the call at the moment, and I felt like I was on the outside looking in, through to today, where I work with not just Snowflake, but all of the other major cloud-based data and analytics technologies out there. And there's a lot of career opportunities for those people that can demonstrate that experience. If only I could have multiple persons, that like myself, that I could send out to different jobs, then make things a lot easier, because at the moment there's just so much work out there, and that's seems to be a global phenomenon at the moment in terms of the amount of demand for really good experienced talent. And so if this kind of process was easy, everybody would be doing this. So why are you here today, and why should you care about this? Well, as I mentioned, I've been through that time-consuming effort. I'm sure you could get there yourself, but it's going to take time, and lots of people don't have that time to spare. So I've kind of packaged up those formulas and took it to the next level, really, to help people really transform their careers by putting it into a Master in Snowflake program. And so these people who join my program really become true experts in the cloud using Snowflake, and they've been able to see massive career growth and an increase in salary. Now, this isn't magic. As I mentioned, you could go off and do this yourself. You could read through all the documentation. You could try stuff out yourself in your own time. You could work out what works and what doesn't. And I'm sure you could get there, but it takes a lot of time to do that. So you can do this in a much shorter amount of time. I've been there, I've been through that pain, so you guys don't have to. And I'm giving you the chance to learn how, starting with today. And don't just take my word for it. Here's some basically some recommendations from people who have been through the program itself. And this was a guy, Aravind, who joined the program towards the end of last year. He basically didn't have any Snowflake experience or cloud technology experience before coming to the program, and he was able to really get up to speed. He was really enthusiastic, participated in all of the demos and calls that we did, as well as going through all the content, and he really got good value from it. And then finally, we've got Govind here, who's based in the US as well. And he was able to really get into the next level of detail with Snowflake. Again, he hadn't touched Snowflake at all. He came from a strong IT background, 15 years experience, I think Govind had at the time. And he was able to get hands-on with Snowflake within the environment, and also share knowledge and ask questions from the other members who form part of the program. And so that's how the program came to be. I wanted to help as many people as I could. I didn't want to work part of a one-to-one basis where I could only help one person at a time. I really wanted to scale it out and work out how I could help more people with my knowledge and experience. I just wanted to touch on this particular slide at the moment. We've got, you've probably realized and seen on LinkedIn, a lot of people post the certification badges when they get a Snow Pro certification. They're produced by Credly, a company that issue those digital badges. They did a survey about the value of a Snowflake certification. And I just wanted to highlight that this little statistic here is that just off doing the certification itself, okay, and my program goes way beyond the Snow Pro Core certification, 45% of those people claim that they got a raise, a promotion, or a new job purely because of that certification. So this program offers you the chance, yes, to get that certification, but it also takes you way beyond that. It takes you to an expert level in terms of the Snow Pro Advanced Data Architect certifications as well. So definitely something to bear in mind if you were questioning what the value is of getting experience around Snowflake. Now, as part of the program itself, we've created a roadmap, something called the Everest method, and it's broken down into 3 particular phases. The first phase covers some modules really where we're talking about making Basecamp and mastering the basics. So this is where I talked about earlier on, Snowflake's quite different, and it requires a different way of thinking and a different mindset. Understanding how Snowflake works and how the architecture and design fits together really is essential to know how to package your solutions up to really leverage the platform to its maximum value further down the track. The second part of the program is all about overcoming those real-world challenges. Data warehousing, data analytics, the challenges and problems are often very similar over time. The technology and capabilities underneath change, of course. And so I'm going to help you and show you and demonstrate how you use Snowflake's out-of-the-box capabilities and how you package them up in a unique way to meet common real-world challenges. And as I said there, this isn't the stuff that you get by just reading the theory on a page on the Snowflake website. This is how you take a number of different capabilities and attach them together and address a common challenge in the real world. Finally, we get into the more advanced modules in the program. We call this scaling the summit and making that summit attempt. Not many people get into this stuff. It's all about programming, advanced performance tuning techniques on Snowflake, as well as we touching upon developing applications as well. So these are the more advanced sections at the end of the program. And like I said, not many people kind of get into that, even though those people working on a Snowflake implementation. But believe me, when you get to a certain scale with Snowflake, you do then need to start rolling up your sleeves and potentially doing some advanced performance tuning as well. So 3 steps then: understand the basics, making Basecamp and getting familiar with the new terminology, scaling the wall itself and anticipating those challenges, which you know you're going to have, but you just need to make sure you've got the tools in the box to overcome them. And then finally, the summit attempt. So this is where you've got those advanced concepts in Snowflake and you know how to kind of really take it to the maximum scale. So with that, let's get into the training session now. I'm going to try and give you as much value as I possibly can in this short amount of time to really make it worth your while. As I mentioned, it's really important you get the fundamentals right, and this is all about the architecture in Snowflake and the 3-tier architecture. So it's quite cross-cutting, and the detail comes all part of the program, but let's see how far we get. So I'm going to cover the 3-tier architecture within Snowflake. The first one is the database storage layer, and we'll talk about how Snowflake structures data and stores structured, semi-structured, and unstructured data into its internally compressed format. We'll cover query processing and the role it plays. We'll introduce you to new terminology potentially around virtual warehouses and their role and how they help you execute and process queries. We'll also cover caching as part of that section as well, which I would imagine a lot of you are familiar with because caching is been around for a long time in terms of database technologies and various other IT applications. But we'll cover what it means for Snowflake. And then we've got cloud services. So this is the third and final tier of Snowflake's architecture. What makes up the cloud services, what they do, and how they coordinate activities across the platform. So, bit of background between the on-premise world and the cloud world. So in the past, you often had storage and compute tightly coupled, and you couldn't have one without the other. So at the start of a project, you had to predict the size of your server and project that future demand on your service for the next, say, 2 to 3 years before you put in your order, you pay your money up front, and then you cross your fingers, hoping nothing changed in the meanwhile. And these were the days where we had data centers and we were buying physical kit that needed to be ordered, turned up, and we rack it in our data centers. Now, this led to over or under provisioning resources, and both are bad. And ideally, you'd want to try to avoid either, but that is quite hard. Bear with me while the slides decide not to work a moment. Okay. So many companies have spiky workloads with the need to scale up their compute resources instantly to cater for short bursts of high demand, for example. The retail sector will anticipate spikes in traffic for Black Friday sales, or reality TV shows will have short windows of time for live voting. And these companies need to ensure they've got a huge amount of resources on standby to cater for the demand. So how can you do that? And it often has become a lot easier now with the advent of cloud computing, because now storage to store data now is relatively cheap in comparison to compute. So you obviously don't want those bundled together. You want the flexibility of being able to separate them. And this is where Snowflake starts to come in. I really like this quote from Norman Foster, who's a real architect, not a data architect. So he's designing buildings and he's an award-winning architect at that. But although he doesn't design computing systems, the challenges he faces are exactly the same. And being an architect is a tricky job. So you're trying to cater for unknown future demands, balancing certain trade-offs, and avoiding building yourself into a corner. And so when I take you through the Snowflake program itself, I'm acting as using the Everest analogy, I'm acting as the Sherpa, kind of making sure you don't build yourself into a corner and you're aware of the decisions that you need to make. And they're not going to be the same for everybody in every environment. It's always going to be slightly different. But I'm going to give you the information, and some of that you'll get today to help you make informed decisions about how you design your architecture for you. I just want to touch upon the difference between ETL versus ELT as well. So in the past, if you asked anybody, 5, 6 years ago to draw a modern, at the time, data architecture on a whiteboard, you would get something like the following, where you've got your flat files and then relational databases. You need to extract that data using a dedicated ETL tool, which sits on its own resources, such as SSIS, Informatica, for example. That tool would transform the data because you were so squeezed with the available compute you had on the warehouse when people were querying it as well. You had to rely on the resources and the ETL tool to do the transformations before you finally loaded it into the warehouse and made it available. But then ELT came about because of the cloud, really, and you've now got a whole range of different data sources, from structured and similar to what we had in the past, OLTP databases, through to semi-structured data, through to IoT event-based messaging, through to unstructured data like PDFs, for example, and social media as well. And because you were able to tap into the resources which are elastic and scalable on demand, in effect, it allowed people then to land or stage the data directly onto the data platform. So take it directly from source, get it onto the data platform as soon as possible, and then carry out the transformations by pushing the business logic down to where the data actually lives and leveraging that huge cloud capability which you have available on tap. So that is how cloud changed that paradigm and the approach of just simply getting data into your data platform and transforming it to a format which makes it available then for downstream consumption. So with that in mind, coming back to Snowflake in the next level of detail, here's Snowflake's free tier architecture that I touched upon at a high level earlier on. Now, a useful analogy here is to think of a delivery service, for example. They operate much like that. And this is where the database storage is much like the mailroom. So this layer is designed to efficiently organize and store all the different letters and parcels, for example, arriving from many different places. And you've got some parcels are very large, some small, some are just normal letters, but they must all find their place in the mailroom. And the equivalent of this in the real world is then you've got your semi-structured data, you've got your unstructured data, you've got very large batch data sets that need to be loaded and stored within that database storage layer. They all go into the same place. You don't need to separate them out for any reason. Snowflake can take care of it. You've then got the query processing layer. This very much acts as the courier or the delivery guy, and this handles the logistics of taking the mail from the sender, in this case the database storage layer, and working out the quickest and most efficient route to deliver it back to the person requesting it. So once it's delivered, it can obtain a response and return that to the sender to let the sender know it's been delivered. Now, the virtual warehouse then is the delivery mechanism, and it provides the resources. So in this case, compute and memory resources that allow deliveries to take place. Now, in the real world, sometimes all that might be required is a bicycle or a van or a truck. Even in special cases, you might have international items that need an aeroplane, for example. And this is akin to the virtual warehouses. You can see on the diagram, we've got different sizes of virtual warehouses. And in Snowflake, these come in t-shirt sizes, which we'll get into a little bit later. But what I mean by that is they come in extra small, small, medium, large, etc. And you need to size your virtual warehouse appropriately to the workload that you're dealing with. Now, those addresses which regularly receive a lot of mail or post are kept in easy access for fast retrieval, and that is known as the cache. Then at the end, we've got the cloud services layer. So you can think of this as the HQ headquarters or the big boss. It's the end-to-end tracking system, which provides oversight across all of the services beneath it. It also ensures that the post is secured for access when in transit. So this is encryption at rest, encryption at transit. And it keeps the lights on to ensure that the mail reaches its destination within the guaranteed timescale. So the reason why I use this metaphor to describe it is because each of these layers operate and help each other kind of coordinate activities to provide a fast querying experience for the end user and as a one-stop shop to store all different types of data. And keeping this metaphor in mind as we look through and get into more detail of each of these layers in the next few slides is really helpful. And if you can understand how the features complement each other, it helps you design efficient solutions on Snowflake as well. And as you can see here, one of the key differentiators of Snowflake is this decoupling of storage and compute. So you can store as much data as you like, and you don't need to worry about how much data is in there. The cost is relatively cheap. But then if you do want to do something with the data, then you bring a virtual warehouse into play, and then you are able to query your data. And we'll get into the specifics around that very soon. But first, let's go back to the database storage layer and start there, because this is where our data comes in. Going back to our analogy we just covered, you could potentially have thousands upon thousands of letters and parcels coming into the mailroom each day, and you'll need a system to store and organize them. Now, without a process to help find a specific item of post, you'll struggle to locate what you need, and very quickly the whole system will be in disarray. Now, this is exactly where the first layer of the Snowflake's architecture comes into play, organizing and tracking where data is stored for efficient retrieval. Now, data is stored in something called micro partitions. These are very small, as you can see there, 50 to 500 meg of uncompressed data. In theory, that's smaller because data gets compressed when you load it onto Snowflake, which we'll cover in a second. And those actual blocks of storage sit on the underlying cloud provider's data store. And that could be, in Snowflake's case, Amazon, Google, or Microsoft. That's completely transparent to you as the user. So when you load data onto Snowflake, Snowflake is a managed service. Behind the scenes, Snowflake will distribute that data into these very small micro partitions, which sit essentially on Amazon S3, Google Cloud Storage, or Microsoft Azure Blob Storage behind the scene. You never see that, you never interact with those cloud services, but it's helpful to know where that data lives and how it works. So once your data is into Snowflake, then you need to do something with it. So that's the job of the query processing layer. It's to take queries that you write, SQL queries, pass them to the cloud services layer. So virtual warehouses, what are these? And this terminology catches a lot of people out because the word warehouse means typically a data warehouse. That's what people immediately think of. But in this case, within Snowflake, it's a virtual warehouse. And that is essentially a bundle of compute resources and memory, so CPU and RAM essentially. Now you need a virtual warehouse within Snowflake to perform pretty much any DML activity on the data within Snowflake. And that also includes loading data into tables. So getting data into your database storage also involves compute, and you will need a virtual warehouse to do that. Caching, again, this concept be familiar to you. So if Snowflake receives the same query again, it can rapidly return the result set to the user without needing to go and find data again. We're going to touch upon caching in a few slides time after we go into more detail around virtual warehouses. And I'll give you the different types of cache in Snowflake and also the caveats when the cache can't be used and is invalidated as well. So first, let's go into more detail around virtual warehouses and what they look like. Now remember now, virtual warehouses are completely independent of storage. So any virtual warehouse can access any data that exists in your database storage layer. You can stop, start, delete, create virtual warehouses. It has no impact at all on the storage of data behind the scenes. So warehouse A, for example, can access the same data at the same time as warehouse B. So when you've written some code, some SQL code, and you need to execute that, or you need to load some data in, you'll need to essentially attach that query or load process with a virtual warehouse so you can actually run that query. Snowflake won't let you run the query unless you have a virtual warehouse attached to that. Now, as I mentioned earlier, the virtual warehouses come in different sizes, small, medium, large, etc. And this directly correlates to the number of credits required to run the virtual warehouse. Now, credits are attached to a dollar amount effectively. And so the more credits you use, the more money effectively you're spending. Now, when you start a virtual warehouse running, the first minute, the first 60 seconds, you're always billed for that. After that, though, credits are then calculated on a per second basis, only when the virtual warehouse is running. So you can start to see this flexibility gives you quite a nice balance between cost and performance. You're only paying for the actual resources that you consume. So once your query finishes, you can choose to manually suspend your warehouse, or as we'll see in the configuration options, you can set an auto suspend time where Snowflake will automatically suspend your virtual warehouse if no queries have been running against it for a certain period of time. And that means you're not charged for any credits against the virtual warehouse. Snowflake itself recommends that you start with the smallest virtual warehouse size first, and experiment with different kinds of workloads and virtual warehouse sizes until you find that best balance between performance and cost. Because you can find instances where you're running a particular query, you can move from a small to a medium, and it will half the time the query runs. And also the cost and credit consumption is linear. So you'll probably pay double the credits for a medium warehouse and a small one. So if the cost is the same and you can run a query in half the time, then it kind of makes sense. And that's why the testing and experimentation around that performance is pretty important. So on the configuration aspect then, let's get the screenshot up on the right-hand side of here. The screenshot that you see is all of the configuration options you need to set as a user for your virtual warehouse. That's it. So you've got, what, 5 specific options there. And there's different factors that can influence your decision when configuring a virtual warehouse. They're often tied to the workload, so your SQL queries or your applications are going to be running queries against your data. And you can have multiple virtual warehouses, each with a different configuration to one another to cater for that. So we're going to run through each of these in the next couple of slides, but just make a note of it in your head, what this looks like. So you've got the size. This is the t-shirt size, and I mentioned earlier, where you charge X amount of credits, and that's where you're using your consumption. Then you've got a maximum and minimum number of cluster settings. They can be set from anything from 1 to 10 in both those boxes, and we'll come back to what those mean in a couple of slides' time. You've also got a scaling policy, which tells Snowflake how to start up and shut down clusters behind the scenes. And there's the auto suspend I touched on before, whereas if your virtual warehouse is idle for a period of time and no queries are executing against it, Snowflake will automatically place it into suspend mode. And we'll go through these now in the next couple of slides, so you've got more detail behind them. So there's a number of clusters. So the number of clusters where we saw you can set a minimum and maximum value, which can be anything between 1 and 10. Now, multi-cluster warehouses, and that terminology is really important if you're going to be doing something like the Snowpro core certification. You'll get asked a lot of questions about virtual warehouses. It will also ask you what a multi-cluster warehouse is. And those are those warehouses that have a maximum cluster setting greater than 1. So you can have a minimum and maximum value for your clusters both set to 1. And that means your virtual warehouse will always just run as a single cluster. It won't have the opportunity to scale out behind the scenes. It will always be at 1. But if you were to set the minimum to 1 and the maximum to 10, that allows Snowflake then to choose based upon demand whether to scale out by adding additional clusters behind the scenes. You obviously pay more for that because if you've got more than one cluster running, that starts to increase the number of credits that you're using as well. So this can be really useful if you've got workloads that can spike rapidly, but more importantly, it's all about concurrency. So if you've got a lot of people and applications querying the data through a virtual warehouse at the same time, then you need to be able to create that amount of throughput to avoid any queuing. To do that, you should set your minimum and maximum values appropriately and take advantage of multi-cluster warehouses then, which can give you more throughput, importantly. So just a quick note again with the certification piece, the Snow Protocol. When you move from a smaller to a larger virtual warehouse, so changing your t-shirt size from small to medium or medium to large, that's known as scaling up, because you're effectively scaling the amount of CPU and RAM within the virtual warehouse size you're choosing. Whereas Snowflake adding additional clusters in this multi-cluster scenario is known as scaling out. So remember that if you're looking to do the certification, keep that in mind. Now, when your virtual warehouse initially starts, it will always provision the number of minimum clusters you configured. And as more and more concurrent connections are made, the need for resources will also increase. So Snowflake recognizes that, and then it automatically adds those additional servers to meet the demand. So this might look something like this. Now you can see here we've got a minimum value of 1 and a maximum cluster value of 4. And we can see that our demand peaks at around 11 o'clock in the morning and then 3:30 in the afternoon. And during that time, more servers are provisioned by Snowflake behind the scenes until it meets the maximum configured value, which is 4 in our case. But in the same way now, as demand drops off, clusters will also be removed. So as demand goes down, Snowflake will choose to decommission those clusters, and as well as saving you money. So you always get that nice balance between performance and cost based upon the thresholds that you configure up front for your virtual warehouse. Let's talk about scaling policy now, which is one of the options when you set up the virtual warehouse. So that scaling behavior that we just covered, you can further influence it and control it by setting the scaling policy. There's two options. The default is standard. This is where performance of your queries will be prioritized over saving credits. So it will avoid any instance of queuing, and it will add additional clusters to your virtual warehouse. The other option, there was economy, and Snowflake will wait a little bit longer before choosing to add additional clusters, but it will also be more aggressive when looking to decommission clusters as demand for resources start to fall. If you've got predictable high concurrency workloads, so if you know between 4 in the morning and 5 in the morning, you're going to have a big spike in workload, and you're going to need to service several connections via a single virtual warehouse to your Snowflake account. You can opt to run a multi-cluster warehouse in something called maximize mode. Again, this terminology is important for the Snow Pro Core certification. So what does maximize mode mean? Well, essentially it means you set the minimum and maximum cluster values to the same number. You could set them both to 10, for example, and that means when a warehouse starts in this mode, it will automatically provision the maximum amount of available resources immediately, in that case 10. So it would start up and all 10 clusters would be provisioned behind the scenes, ready to accept that high concurrency workload. So what if you've got predictable workloads, but it's just a single connection? So there's no need for the high concurrency. So in this case, you would be able to create multiple virtual warehouses for different purposes and isolate those resources in doing so. So this is a kind of a design pattern that I see quite often. You can have a virtual warehouse for your data ingestion pipelines, and that can be configured in a certain way to meet that workload. You could have one for your finance department where their profile and workload is probably going to look quite different to your data ingestion pipelines. They could be just running a dashboard query through Power BI or Tableau. You know, not that many connections, quite short, sharp, and you may well want to configure your virtual warehouse differently for that department, as well as for marketing and so on. Now, by separating those workloads out by using dedicated virtual warehouses in this way, it removes any contention because there's no competition for resources. And it also provides greater flexibility because you can stop and start as you need to and configure those values differently that we've just been through. But you also get credit control. You also get more control and visibility around credit usage. So as I mentioned earlier, the time that you have your virtual warehouse up and running for, that basically costs you money. You can also get real visibility over how much your ETL tool is costing you, your data ingestion pipelines, how much is finance costing me in this department and that department, and really get a good, clear sense of where that demand lies and how you could potentially optimize your environment even further. I mentioned earlier, you can stop, start, even resize any of these virtual warehouses completely independently, and there's no impact to data or users in terms of changing the size as well. So this is the dedicated warehouse model. I've seen this in the real world use quite often. Some departments have a centralized service, a data warehouse that's, for example, running on Snowflake, and they offer these services to the business in return for a cross-charge model based upon how many credits they consumed. So in this case, the dedicated virtual warehouse approach for each department worked really well. Everybody had their own resources, and we've got visibility over the number of credits they consumed. So it was very transparent, very easy to manage, and it also guaranteed the customers a constant level of service, because if finance have got their own virtual warehouse, let's have a look at this diagram, then nobody else can compete with those resources. So they're only competing with themselves. So they can kind of manage that pot of resources themselves as well as their credit spend. So that's an illustration of how that could potentially be configured and set up. Finally, our final option on our virtual warehouse was all around auto suspend. And you can choose to suspend any of your virtual warehouses from running. You can do this manually, or you can do this automatically by setting the value for this auto suspend parameter. And this can be useful when your warehouses may not be queried for large parts of the day. You wouldn't want them running all of the time because that's costing you money in terms of credits. So you could use a small time increment, such as the default of 10 minutes. It would make a lot of sense if your virtual warehouse isn't being queried for a long period of the day. And in that case, Snowflake will just automatically place your virtual warehouse in a suspend status, and it's not charging you any money. I often get asked, why don't we just set it to a very low value, like 1 or 2 minutes? But it doesn't really make any sense. You build for the first minute anyway, and that creates a little bit of latency when you're waiting for the underlying resources to fire up. And your warehouses will be continually starting and restarting. And that can also have a detrimental effect on the result cache. And it's important to consider how many queries are taking advantage of the cache, and build that into your thinking when deciding on what value to set for your auto suspend. So caching then, so we just touched upon it there, and let's go into the two types of cache within Snowflake. One is the result cache that we just mentioned before. The other is the local disk cache. So going back to our postal service analogy, the cache is for those places that frequently receive a large amount of the same type of delivery. We've seen it before. We know what it looks like. We know how to deliver it. So we create that special section for it in the mailroom to promote efficiency. So in a very similar way, when a query is executed against a virtual warehouse for the first time, the virtual warehouse generates a query plan and goes and gets that data, puts it into the cache, and then sends that result set back to the end user. When Snowflake receives that same query again, it can then quickly go to cache. It doesn't need to worry about going back to the data. It actually then doesn't also need to use a virtual warehouse, because you don't need to use any resources to go and fetch that data. You can deliver it from the cache again. So utilizing the cache is really important and can also save you money as well as improving performance. Now, some caveats around the result cache. So it stores the result set of every query executed in the last 24 hours only. And if a user then submits a subsequent query which matches the previous query, then it will make that attempt to retrieve the result set from the result cache. However, if the underlying data which makes up the result set, if that's changed since the last time the query was run, that will invalidate the result set held within the cache. So it can't use it. It needs to go and fetch the data again. Similarly, if the query contains a function which needs to be evaluated at execution time, You may know this is referred to as non-deterministic. So this is something like an equivalent of a get date time, for example. Then the cache can't be used because the query optimizer can't evaluate that until execution time. Obviously, the user executing the query must have all the correct privileges for the tables used in the query as well. And interestingly, that the result cache is not specific to an individual virtual warehouse. It actually serves the whole environment. So if you've got multiple virtual warehouses running, one of those virtual warehouses can tap into the result cache as well. So it's not specific to a virtual warehouse. Whereas the second type of cache is, and that's called the local disk cache. Now, this cache is used to hold the results of SQL queries. The data is fetched from the remote disk, so that storage layer, and it's cached within the local SSD, solid state disk of the virtual warehouse. You don't have a lot of control over this. Snowflake does this behind the scenes. The only visibility you get from this is if you look at the query plan after you've run a query. So Snowflake will try to do this optimistically just to try to improve performance behind the scenes. Finally, let's just touch upon cloud services, the third and final layer and the role this plays. And this is the collection of services that ties everything we've discussed so far together. So don't forget, it's the head office, the brains of the operation, and it covers the following. So authentication and access control. And this manages the service which allows users and applications to log on to the Snowflake platform. We've got infrastructure management, which looks after the management of those underlying cloud infrastructures, including storage buckets, and provision and decommission of clusters for virtual warehouses, as we spoke about the multi-cluster virtual warehouse. Metadata management. So this service is collecting metadata all the time when Snowflake is up and running about the various operations that are carried out on the Snowflake platform, such as who's using what data, what users are logged in, when was the table last loaded, and is it being used, for example. Query parsing and execution. So this service works out that most efficient way to process queries. It parses the queries to make sure there's no errors, for example, generates the query plan. It manages that end-to-end query execution via virtual warehouses. And then finally, access control, which is denoted by security here. And this is the service that ensures that users can only access or carry out operations on the objects and data they're permitted to based upon their privileges. So with that, then let's go into a tiny bit more detail around the Everest method. Now you've got that background and context. So those 3 phases I mentioned earlier that make up the Everest method, they're broken down into 10 modules with lessons within those. So we start with a real deep dive, and I've scratched the surface today and hopefully found that valuable in terms of the Snowflake architecture. Then we've got data loading into Snowflake. So until you can get data into Snowflake, there's not a lot you can do with Snowflake. So catches a lot of people out, and it's really important to know the different ways you can get data into Snowflake, the different trade-offs around that as well. Module 3 covers data movement, how then you identify changes in data within Snowflake, how you orchestrate data movement between different layers in Snowflake as well. The midsection then is all about those kind of common kind of challenges and how you anticipate those. Module 4 covers a lot of the specific Snowflake, quite unique capabilities, such as time travel and cloning as well, and how that can help with a number of common challenges, such as creating non-production environments and protecting your data as well. Module 5 is all about extending the role-based access control model out of the box. I see a lot of people getting into a lot of problems with this and a lot of complexity. Basically, I talk you through how to best do that, share my pattern with you. You can download all of the code and all the patterns that I use in my enterprise scale clients for your own use. Module 6 covers SnowSite, which is the latest web UI you may have seen or heard about from Snowflake. And then Module 7, again, quite unique to Snowflake, all about data sharing. And there's no file transfer, no movement of data. It all gets shared through Snowflake's backbone and infrastructure. And it also allows you being able to monetize data effectively as well. finally those advanced features and basically approaches that I mentioned around looking into performance tuning. We go into a lot of detail around that and certain tactics that you can use to identify poorly performing queries, being proactive about it, and then what to do when you recognize those symptoms. So based upon that, I hope you really get the fact that, you know, what I teach in the program is just not theory. It's not stuff that you can just read online or pick up a Udemy course. Is actually quite different. Until now, I've only really shared this system and approach with my one-to-one clients, and you know, now I'm sharing it with you guys, just because I can make a greater impact and effect. So it's time and tested and proven in the field, and I use these methods and systems every day, and I'm continually refreshing the program as new features and functionality comes out in Snowflake. So if you're thinking I'm ready and where do you start? Well, I will get to that in just a moment. So I just talked you through that Everest formula, and I'm sure you can imagine that's just the tip of the iceberg. So you could either do it yourself or follow my proven success path for you. So if you're one of these people and you really kind of want to get to that next stage in your career and take that ultimate step, it's all about investing in yourself personally and getting to that next stage. And I'm looking for people who are actually going to take all the information I give them and actually implement that information and allow me to support them and work with them to get to that stage as well. So here's how the process works. If you want to get in, there's an application form, which I'm going to paste in the chat now. You can fill that out and we can review it, and we will let you know if you get a place in the course. I'll also message you the link to the recording of this webinar session, which I'll upload to YouTube as well after this. I've just pasted the link in there. Just ignore the fact that it gets pasted with a large font. But I will get in touch with all of you individually via LinkedIn, send you the link to the recording of this webinar. I'll send you the link to the application form as well. And hopefully you found that useful. And then we'll use that information in from any application forms that you submit to review it and see if you are fit together to work within our program. With that, thanks so much for making the time to take this hour out of your day. I really hope you got some value from it. We've got 8 minutes left, and I'm happy to answer any questions that you may have on the call in any order. Just come off mute and just feel free to ask me a question about the program or anything else about Snowflake that you've got. Don't be shy. Any questions? I'll give you a couple more seconds for anybody else before we close the call.
Adam.
Hello, Rajesh. How are you doing?
I'm doing good. Thank you for asking this. So, Adam, just one question. What is the months of duration for this course? How many
Good
months?
question. Yeah, great question, Rajesh. So the core course content is all recorded and available on a training platform online. You get all the members will get lifetime access to that, and that includes all and every update. It's all video based and tutorial based with downloads, as I mentioned as well, so you can follow along yourself, which I would encourage. The other two components to the program is a live 60-minute weekly group consultancy call, exactly like this, where I'm having a live call. Any members can turn up and ask any questions they've got, either about Snowflake, interview advice, certification advice, anything data analytics, because I use a range of other tools outside of Snowflake as well. And you can come on to the call and ask any questions you've got. All those calls are recorded and made available as well to all the members to consume. And finally, you get part of a private LinkedIn members only group where you can ask any questions again about Snowflake or other technologies or architecture advice. And me and the other members then can also help provide guidance. So with that in mind, to come back to your original question, it tends to take people between 2 to 3 months in total to run through all of the core course material. He are spending about, on average, 4 hours a week, roughly. And it all depends upon the starting point, Rajesh, that you're coming into this. As I mentioned, a lot of the members who join the program have 10 to 15 years experience. That's not a prerequisite. The prerequisite is you've got a good background in working with data and analytics, commercial databases, and you can kind of read and understand SQL. I provide all the code anyway, so it's not super SQL intensive to that degree as well. So it's between 2 to 3 months for an average of 4 hours a week. That would allow you to go through all the course material as well as practice in all of the demos. But like I say, there's no kind of end date. It's constantly growing community. The community is at the heart of everything that we do, and that's why we have invitation only. We have a members group. Everybody's on this journey together, supporting each other. So hopefully that kind of helps give you a bit more detail, Rajesh and everybody else on the call as well. Okay, any other questions from anybody?
Yeah, this Puneet, does it cover any certification requirements, like any particular certification patterns, anything like that?
Thanks, Puneet. It's a good question. So it goes way beyond the SnowPro Core certification in terms of the information I give you as part of the program. It's more in line with the SnowPro Advanced Architecture certification. As part of the program, I also give you, I call out all of the things that you need to be aware of for the SnowPro Core certification during the material I've been through. And we've got a lot of members who join with no knowledge of Snowflake, and within a month or two, they're pretty easily completing the SnowPro Core certification. And I would definitely encourage you to kind of do that and just kind of underline your experience. The other thing that you will get as part of joining the program is free access to my practice exams on Udemy course as well. So nearly 2,500 students have been through that so far. So you will automatically get a free voucher as part of that to redeem and use that as well to support your learning. So it is absolutely structured around those people that want to do a certification as well.
Yeah, thank you.
Good question so far. We've got a couple of moments left if anybody else has any other questions for me. No? Okay, guys. Well, listen, thanks so much for staying right to the end. Grab that link off the chat if you want to apply, and me and my team will definitely take a look at that and come back to you pretty quickly. I'll also follow up on LinkedIn with all of you with a link to the recording once I've uploaded it to YouTube. And again, I'll include a link to the application form, and you can always come back to me offline if you've got questions around it. In the meantime, enjoy your day or evening wherever you are in the world, and I really appreciate your time, and thanks so much for staying to the end. Thanks very much, guys.
Thank you.
Thank you.